online, you want to search and get data, the truth is you actually don't find data. You find data from other countries or other areas. So this is what motivated this research. I am going to, the architecture which we are talking about is just an environment where researchers can deposit a data into the portal, and those who want to mine that data won't have to spend another year to try to understand the data. What we want is, if, for example, I finish my master's or my PhD, because there is a lot of data that is generated from that, I can just post or send that whole thesis to whoever has the system that we are talking about. Then from that system, it will mine that these are the findings. This is the data which was collected in this research. And it allocates or it spreads the findings into the system. Then when one wants to research and do research on that particular field, then he gets the data available. So the most important thing is there's no machine learning without data. And if we don't have data and data sets, then we are going to have huge troubles in getting the needed solutions that we are asking for. This is just a brief background in the study. I think this is what is going to be covered. I'll give just a short background of what's happening in the machine learning space and the challenges which we are experiencing, the benefits of using open data sets, the issues of ethics. We always think of ethics as the last resort, but if we are to have reliable and valid data, I think we have to start prioritize ethics when we are starting. Then we look at the future aspects and what. Once I start moving, I'll move faster. I'll skip some slides. There are too many, but the whole purpose is to give you an understanding of the importance of having data sets which the region can rely on. When I was doing the presentation, I made some notes. So I apologize for this ugly slide. You won't see many of them again, but I needed it because it was my writing notes. I wanted to check what is happening in data sets. Do we have any data sets in South Africa or in Southern Africa or for Africa? So the deep learning Indaba, which is hosted every year to try to grow data, machine learning and what research in the region, they have documented a number of existing data sets which are there where you can go and get data. So one of them is the Masakwa News, which is about classification of languages. There's one which is called South DB, which is I think if there are Nigerians in the house or on the online, there are a lot of dialects and accents which they use. So that data set focuses on classifying the accents which are used from the Nigerian point of view. Then there is machine learning translation benchmark. Then there is Chichewa. Chichewa, those who know, it's a language commonly in Malawi and some parts of Zambia, I think. And when you look at all these, you can see that these are mainly to assist in language. But now, what about me? I am passionate about health. I am passionate about agriculture. I am passionate about education. I want data sets. I don't get any data sets. If you go to Kagyu, the most popular data source, you find that there is a lot of data that is there. If you just say health status, health, agriculture information, it retains a lot of data. The moment you say in Namibia, the numbers drop to even 0. And that's the challenge we are having. And we are saying we want an environment where Namibian researchers, when you have research, you just push whatever you have. And when you push that, the system will do its work and classify, and we have a data set which is already sorted. The background, in South Africa, I think those who are from South Africa, or if you hear what they call load shedding, and there have been debate on this load shedding a lot. They have used now the Delstat data set to try to predict which areas should be shorted, which areas should be based on the data which is available. So they have now started applying this to manage electricity in that. So they are, of course, as an appreciation from machine learning, a lot of work, there is a lot of work which is being done by researchers, and publications are coming through in terms of machine learning, AI, and big data and all those. But still, the main problem is this is not translating to us having the needed data sets. That's where the challenge is. We are saying the region, the African region, is faced not only with the language issues, which you see the common data sets coming. There is an issue of poverty. Poverty, we may take it for granted, but it's very key, because if it's poverty and say learners apply for government, when they finish matric, they want to go to universities, they apply for government grants. The government system use the issue of poverty to know who should be given the bursary. So if we have good data sets on that, then we will be the issues on education, healthcare, crime, and all that, which needs adequate data sets. So there is a lot of that. Now, based on that, we find that we have a lot of challenges that are resulting to us not having open data sets. So these challenges are, as a region, the Southern African region, we don't have the infrastructure like you have in this building. You see, you go to many institutions, we don't have many institutions with infrastructure that we have here. So that's a limiting factor. So you can't even talk of or having an open data set when you can't have the infrastructure. The data quality, remember, most of the researchers, when they are collecting data, they are only collecting to satisfy their qualification. This is why once you get your master's, you do the celebration and that is it. But there is a lot of wealthy data which can be used after your master's and what. But when you are doing it for the masters. If you do it with the intention of saying, maybe in future, someone is going to use the data which I have collected, then it might assist in improving quality. Then ethical issues, we hear a lot of ethical issues as we move, because they really affect they come as a challenge. There's what we call data curation, where we are looking at lack of standardized curation practices. How do I upload the data? How do I, because we don't even know. We don't have such an environment. Resource constraint talks to the infrastructure, governance, ownership. Remember, if you say many, if I just say out of this, most youth who are dying at the age of maybe under 30, they are abusing drugs in Namibia. You hear the Minister of Education, of Health coming to the podium and try to question that person. So we are looking at data governance and ownership, where we say there is need for that governance and structures, so that, because it's nice when it's just about research, but it's very dangerous when it comes to the results. When you pronounce the results, that's when people say, hey, but how was that data collected? How was it? We are saying we want to build an environment already with the understanding of data governance and ownership. Who is responsible for what? Do we have those structures? If I want certain data in Namibia, in South Africa, in Angola, in what, where do I go? Do we know where we can go? If we don't have that, then we are going to spend lots and lots of time trying to do some of these things. Data accessibility is another challenge, but we are saying if you do open data sets and you have them and you know where to go, you benefit a lot. There will be a lot of benefits, which majority of them are going to be availability of data, which was a problem there. You have data available. You have it's not one person or entity or institution that will do. So it already established collaboration like what we see in the morning, where industry, government, and academia come together. So that's the beauty of having this whole model of open data sets. Now we also empower communities, because remember, if they know that whatever they are going to give you is going to later be published or later be shown to assist them. We have many of our parents and grandparents growing mahangu in a field for 50 years, just mahangu, right? And you ask them, why do they grow? They will say, no, my parents, their parents now, which are your grandmothers and what, they used to grow mahangu. But is that so? Even when they grow, they told you they work hard in the fields and they harvest very little, right? They are growing mahangu on a soil which is not even good for mahangu. So if they participate in this data collection and they know that it will have an impact, we will develop a recommender system on the best crop to put on their environment. Then they will contribute and participate and give you quality and good data. So community. The problem with us researchers, we get data, we forget where we collected the data, we come back, we sit, we submit, we get our masters, we celebrate, and that is it. Do we go back to those communities and say, thank you for the data, and we only put in the acknowledgement and they don't read, unfortunately, because they will be in the libraries. What we are saying is, if we do this well, we are going to have communities fully participating because they understand the benefit of what we are doing for them. Then we won't fight on ethics because we have standards, we have processes. At times, you interview a person like it's a secret because you don't want them to know some of the things behind the research. So that is what we are saying. If we are to have open data sets, we have to be very transparent. We have to be very open with the people, and they will be also open to us and give us the data set. It has then a huge impact of giving us driving the economy and giving us the needed benefits. We should have saved or helped, the data which we have even as universities in our ITS system can even easily tell that some certain learners from a certain high school, they won't finish their qualification, they will drop out. We have the data to show that. But what do? We keep on taking, accepting them, and they keep on deregistering, and as if we are not having the data. What we are saying is institutions will be able to make very powerful and very good decisions because they have the needed data. So it will assist on the economy. The ethical issues, I think I will not cover this. All I will say is important to address ethical issues when you are proposing to have open data sets, because it allows you, people who accept the results and the data which you are going to have. I will be skipping because I am guided on the time. So I just need to. The impact of having the open data source, you have then an enhanced or increased diversity or diversified data source. You have an environment, take it as a port which is just where you go and mine and cook and grab what you want. So you have that environment for you. You are able to collaborate with many people because data is not owned by one person. So you need to establish those systems so that data is those who are involved in bringing the data understand. Then the issue of empowering local expertise, we covered that. Then the issues of economic and technological advancement. If you do use AI and machine learning systems adequately, they will assist to save a lot of things. People are losing money, businesses are losing things. For example, in South Africa with load shedding, which can even, because of the data and the experiences which are there, people will be able to say, hey, the environment is strained and we need to do this before we do load shedding. One good example of effectively using the data that we have, I think those who have been following US elections and even the recent South African elections, CSIR, which is one of the key data environment, they're actually busy creating this open data portal with 5% of vote counts. At least 5% of vote counts, if our count in South Africa, they were able to predict how the elections, the results will go. And they presented, I think, 2 weeks back, where they were saying their margin of error was just less than 1%, just close to 1% for all the overall results, which means anyone who has good data can be able to use then machine learning to be able to collect the data. I think because of time, I'm not going to go. I have a lot of other slides, but if you allow me, I'll just skip. And maybe just hold chair so that I just do what we say is required. We need people, the networking and the knowledge exchange, the partnerships, then the research and development in AI. Then we need policies that talk to machine learning governance and what. The most important thing that Southern Africa lacks is the needed skills for the people with capacity and capability to do that. So let's invest in training these people, the youth of today, so that they have the interest in machine learning and all that. And we build the architecture which we want. And it's the architecture where I will post whatever I have and it screens and sets and put wherever, whatever belongs to where. And in the end, we have data sets for Southern Africa. Researchers can go there and try to solve problems that talk to Africa. Our main problem is we don't have reliable data sets despite the many problems that the region is facing. I thank you.
Okay, thank you so much, Prof. Norbert. We have listened to the presentation, and thank you for underscoring the importance of data set in machine learning. Before I will open the floor for anyone who has a question, I would just like to find out from you. You have underscored the fact that the machine learning heavily depends on the data set. And you are talking of an open data set. That is, different contributors can contribute into this data set. How do you ensure the accuracy of this data set? Because it's coming from different sources and they might have carried out or gotten the data by different means. And so how do we ensure that this open data set will contain the correct accuracy, since our machine learning will depend on that?
No, thank you, that's the back end. So the architecture which we are proposing should have the set fields that are acceptable for any data set which we need. So you need to have then those specific fields set right. So if ever someone is going to bring then something that is not right, we need at the back end, before that data can be pushed to the to be open, it must be cleaned, and that cleaning requires best machine learning algorithms again. That's why we need people with the skills at the back end to set up for us such an environment.
Well, okay. Yeah, thank you so much. I will now give the opportunity if anybody has a question that want to find out or contribution to the presentation. Do I give to online first and then those who are on site? Maybe one question from those who are online. If you are online and you have a question, maybe I can see by a raise of your hand, then I will call you up. I don't seem to see any question online. Maybe I will hand over to those on site. If there are any questions, please, you want to ask from Prof. or you want to contribute to the presentation, you can go ahead.
I can assist you, Chair. There is one hand I see.
Oh, okay, go ahead.
Great. Thank you, Prof. for the interesting presentation.
Maybe I able to hear him.
I am getting him faintly, but yeah.
Okay, no, I think he is coming to the. Okay.
Good.
All right. Am I audible?
Yes, I can get you now.
All right. Thank you, Chair. Thank you, Prof. Jerry, for the presentation. My question was on the. I would like to maybe more clarification on the infrastructure. I understand, like, even from our keynote presentation, one of the things that we know, like most companies, especially from the West, they are now having like some offshore storage facilities to help in the cooling and keep these large data sets. Is they require a lot of processing, like of the data, and because of the large volumes that are required. So does the framework takes care of the infrastructure, probably in terms of like the large costs that are involved and how the collaboration can be done, let's say within Southern Africa as a whole, since it's a collaborative effort between governments. So how does the framework takes care of that? Thank you.
Okay, thank you. Yeah, I think, okay, so the question is on the resources. And I challenge colleagues who are, in response to your question, colleagues who are having students who are doing data science, machine learning and what. One of the simplest thing which we can help them is to give them fast processing computers. You want them to do machine learning, you give them an i3 laptop. It's not going to work. So these are the basics which we are saying, yes, as the region, we find ourselves in a very, very constrained environment that universities, for one of our students in the labs, for us to buy i7 laptops for them, we had to write, I think, 17,000 motivation after motivation. So our managers do not even understand why we need all this. So it's a problem, and this is why we are saying it goes back to the governance. They understand. I'm talking of those who approve what we submit. If they understand what data mining entails, then they should support the needed equipment. I'm not even going to where you were asking about what happens at the back end, the cloud, the storage, the what. it starts from a laptop that a machine learning data science student is using. If we can have an appreciation of that. So in the framework, yes, obviously, we are making it as one of the key points to say there is need for infrastructure to be revamped. There is no machine learning learner or researcher who can learn in an environment without internet. But now if you start selling data and all that, we are not going to achieve what we want. So internet accessibility must be available and everyone should have internet when they have. So such things are required and obviously yes recommended in the framework. Thank you. Okay, so sorry, Chair, there are two hands in the house, I think.
All right, we can just quickly take the two hands so that we can move on. Please, the two hands, we can quickly take them briefly.
Or you can.
Okay, mine was still on the infrastructure. So I wanted to understand if you have already thought about which kind of infrastructure should be put in place. Because as I recall when I was still student, in some of the South African institutions, they did have a peer-to-peer network, where an institution, for example, can have this data stored in a server, and other university, open to other universities, who can access to those data and then try to run the applications. So I don't know why we cannot think about that peer-to-peer network instead of thinking about the cloud.
Yes. Okay, so yes, the point is, why would we want to repeat setting up an infrastructure, for example, where it's already there but not even fully utilized? So nasty as an environment here. Why should you now start again having own environment and what instead of utilizing the same resources? So why should us not share existing infrastructure? Then we invest in building the infrastructure and we say, if you want best infrastructure where your data environment is, go to NAST. So there is no point for the government to then go to any other person and try to invest what is already here. They can just improve on what you need. So I think the South African model led by the CSIR, they are trying to get that and make universities aware that they are developing that data environment where people should come and go to. So that's what we need for the whole region to happen.
Okay, thank you so much, Prof, for the presentation. My question has to do with your research methodology. The methodology you engage to gather the data from the community or you propose to use. I want you to just enumerate on that. And then in that, since the expectation is that the data set, the open data set is going to be very large. Is it not? And then if you are going to gather such a large data set from the community, in line with the question raised by the chair, how do you ensure validation of the data set? And then, are you going to consider letting pilots? You are using a particular methodology to gather your data set. So is pilot part of the plan, pilot studies?
So I'm requesting to session chair, please strict on time. So we are running behind the time.
Okay.
So please,
okay.
please.
Okay, are you considering pilots?
Any question they can discuss during the lunch and please.
Okay, yeah, I think Chair, then I can we can discuss offline. Yes, but we are considering that. Thank you, Chair.
Okay, thank you so much. We see that there is quite an interesting point of discussion. We can continue our discussion during the lunch time. So I would like to call on our next speaker, presenter, Professor Kumar Mishra. He's a professor and Director of Symbiosis University of Applied Sciences, Indore, India. Is also the Director of Computer Science and Information Technology. He will be presenting on the topic Machine Learning Made Easy, a case study on computer vision in AWS. The biology of Prof. Kumar. Prof. Kumar Mishra has received MTech degree in computer science from the DAVV Indore in 1994 and a PhD degree in computer engineering in 2008. Presently, he has been working as the director and professor SCSIT, Symbiosis University of Applied Sciences, Indore. He was founder, director, Microsoft Innovation Center at SAIT, Indore, India. He is associated with Namibia University of Science and Technology as the Program Advisory Committee for Doctor of Philosophy, Computer Science. Is ex-visiting faculty at IIT Indore. He has 30 years of teaching and 15 years of research experience with a good number of citations with H-index and I-index. He has 4 patents granted and 12 published jointly with PhD students and more than 100 papers in referred journals and conferences in his research field. His PhD is in secure multi-party computation for preserving privacy. He has organized a number of IEEE ACM and Springer conferences in the capacity of conference general chair and editor of conference proceeding. He is a senior member of IEEE ACM and CSI and held many positions like chairman, IEEE Computer Society Madhya Pradesh section from 2022 to 2023. He has been IEEE MP subsection 2011 to 2012 and chairman IEEE Computer Section Bombay chapter 2009 to 2010. He has been chairman of CSI Division 4 Communication at National Level 2014 to 2018. He has been also the National Treasurer, Computer Society of India 2019 to 2021. At present, he is the chairman of IEEE Madhya Pradesh section and chairman of ACM Indore chapter. Dr. Mishra visited and delivered his invited talk in Taiwan, Bangladesh, Singapore, Indonesia, Sri Lanka, Nepal, the USA, UK, and France. He has authored 2 books on database management system and programming in C and C++. He edited 12 international books of Springer publication in his domain of computer science. He has been a consultant to industry and government organizations like the Sales Tax and Labor Department of the government of Madhya Pradesh, India. He has been awarded the Paper Presenter Award at international level by Computer Society of India. He has a long biographic data, very, very rich.
Thank you. Thank you.
We are it will be interesting to listen to you, Prof. Kumar. Can you go ahead? Please, you have 20 minutes for presentation. Thank you very much.
Okay, thank you, Professor, for the good introduction. Now, am I audible?
Yes, go ahead, please.
And my PPT is again is visible?
Yes, it's visible.
Okay, thank you, Professor, for the nice introductions. My topic is, today's topic is machine learning made easy, and with the case study of the computer vision in AWS environment. Right, this topic, before studying this topic, because this is a topic of this slideshow. I will go for the slideshow mode. It's visible in the slideshow mode.
Yes, it's visible.
Okay, right. Now, this second slide is this. What I'm giving some quotation of this. What is the value of data is there? We are saying data is the knowledge that could change the life of the patient in the case of healthcare. This is one of the quotation. And the another quotation, we can say information is the oil of the 21st century. And the analytics is the, that is very important thing is there when we are saying data and the informations. The consumer data will be the biggest differentiator in the next 2 or 3 years if they are using in their own for planning and strategy. Like without the big data analytics, companies are blind and deaf. Wondering on out of that traveling, what's the my opinion is the data is going to
Chair, we
become
are
the,
still on the show.
data is going to become the currency in the future, right? Okay. So this is what we are saying, and how machine learning is very important if with the data is there. I am taking the example of the computer visions. We are having the AWS Academy in our campus, and we are working on AWS environment. So how machine learning and how the data is very important in the computer vision, we will discuss. This is what we'll discuss, the introduction of computer vision till the face recognition if time permits, right? So this is what the computer vision is. This computer vision is the automated extraction of information from the digital image. From the digital image or video or something else. Now you can see in the after COVID, this computer vision is playing a very important role where every transactions, everything without touch, we are going to do that. So with this computer vision, that's very important topic of the machine learning and the important topic where we are going to process the data, live data. So this, if where the computer vision is implemented, if you talk about the public safety and the home security, every day we can see the CCTV in your home, right? And CCTVs are there in the road of for the traffic control is by the this camera and all these things, and we can capture the data. We can capture the data and we can process it and we can take some decision on that. Right? I have also developed one model for the smart city here to capture the data in the traffic and then transfer to the controls panel, and that will decide automatically and put the challan and all these things. That is for the authentication, we can use the computer vision. That is for the interaction and all these things. For authentication and enhancement, this computer human interaction, we can use this computer vision. And then content management analysis is also there. This nowadays is very popular. Nowadays is very popular. That is autonomous driving. There is a Google car is very famous, right? This autonomous driving is also a very good example of how we can take the data, and then how we can move the car without driver, right? That is very important. For the medical imaging, right? In the hospitals, lot of computer vision is there. Even in the COVID, you can see that doctors are not visiting in the hospital nearby the patient, but the robot is going there, right? One of the robot is designed in my city that by the 10th school students, and that robot is playing the role of the doctor, right? So that is very important. Manufacturing process control where their computer vision is also very good example for that. Right? These are the some few examples where the computer vision is there, but nowadays everywhere when you are moving from one place to another place, the computer vision will play a very important role. There is third eye is there, right? So third eye is able to see to everyone. If we are thinking that nobody is able to see you, but the third eye is there, is able to see, and we can process it very fast. So in the case of computer vision problem, that is content recognitions. So what this is a plate we are having in the front of me, that you can say either this is a lunch plate or this is a dinner plate, or you can breakfast or something else. But how we can identify, how computer can identify whether it is a breakfast or some lunch and all these things. So we require the data. We have to process it, and computers can identify after capturing something that is known as object classification. That is the one thing is object classifications. You have to classify the objects, right? So when now say you can see in your mobile also, there is a one box when you are putting your camera and you are clicking the pictures, then there is one box will be there, and that box indicates you that's face identifications, right? So similarly, we can identify the object detection we can do here. This is known as object detection, is known as bounding box. That is a top, left, width, and height. If you get this point, then we can clip that particular image, and that image we have to detect it whether this image is of what milk, of glass of milk or bread or something else, and that we can map with our database. In our database, whether this is bread or this is another objects, right? So, and you can see in the left side, this what the confidence is there. This milk is a 97.1%. This is a milk. This ice cream is a 97.1. There is a bread roll is a 94.5. Some type of computation is there after capturing all these things, the object detections. And AWS can play a very important role here. Amazon Web Services, right? Object segmentations. The precisely we can do that. In the previous case, this is rectangular box is there. Here is exact cutting is there. You can see that, right? So this is the third one is object classification, object detections, and object segmentations. Another is that the computer vision cases are there. Content recognitions, right? We can find out the path of the particular player, how he's playing, how he's striking, and all these things. You can capture the path of the people in the scenes, right? You can use the movement of every player, right? That is known as instance tracking. So after that, the coach will guide him how to play, right? How the other person will play, how to face to others, right? So this is what the computer can automatically can detect and then alert to the player. Action recognition in a mall with the help of the behavior of the walk and all these things, right? Analyzing the shopper behavior and density in the retail store by studying the path that each person follow. We can do that with the help of action recognition in this. These are motion estimations, we can do that. This in the computer visions, again, then data is required. If data is there, then with the help of this motion, how we can see that which type of shot is there, okay? So this is what, how to analyze it. So in the, that is in the AWS, there is a one of the API is there. One of the tool is there that is known as Amazon recognition. And this Amazon recognition will what analyze all these things. This is ready-made model is available in the AWS. This managed service for image and the video analysis, right? That's a type of the analysis that may be searchable and videoable video library. You can see that. You can see that face-based user verifications, right? We can identify who is there, who is not there. You can see in a lot of mobiles, if you have stored some names with the pictures, when you are clicking the pictures, it will show the name also, right? So it will analyze it. Even in the Google, you can see that the Google is able to classify the pictures based on your face, right? So face-based user verification is very possible. You can see that sentiment and the demographic analysis is also there. We can see with the help of face, right? With the help of face, we can get female, male, eyes, happy, smiling, and all these things we can do that. So we can apply, suppose in your, this is some type of play, some type of, if you want to play some song, then automatically it will detect whether your face is sad or happy. Accordingly, they will play the song and like this, right? This type of applications are there. These unsafe content detections, right? So with the help of this, we can use unsafe content detection that will be very useful for the children's, what they are searching in the entire net and all these things. Text detection is also there. You can see that text the number of the player in the topmost pictures. We can find out that the 5022, it's one type. This is a name of this particular player is this, right? Okay. So text we can detect in the image. Okay. So this is what we can do with the help of Amazon recognitions in computer vision. We can do it, right? Security and compliances is a very important where the computer vision will play the role, right? We already discussed about that. Everywhere the camera is there, and this camera is taking the live streaming and analyzing it. When I was in Singapore, then I have seen that in the airport, the robots are there. They are capturing the image, and that image is transferred to the control room. And control room even can recognize with hair, without hair, with braids, and all these things, right? So this number of different variation in the face they can recognize in the database, and the database can find out whether this are the genuine person or there is some doing misconduct. Can do that. Okay, this can be add a powerful visual analysis of your applications. We can use this Amazon recognition can use in the .NET, PHP, Python, JavaScript, Node.js, C++. Even we can use this software development kit and then can use in your applications, right? So this is one case. Because we have the running of sort of time. So searchable image library, we can see that we can capture the image from the mobile app, and this Amazon S3 is the storage where we can store the data of this all type of applications, mobile pictures, and AWS Lambda, AWS recognitions, and Amazon Elasticsearch services are there. With the help of that, we can classify this image, and then Amazon recognition will classify this image, and then this predict that this image is of what. You know, this Google phone is having this type of applications. You can access, you can click the image and it will give the information and all these things of all different parts of that image, not only single image, right? So this is searchable image library is there. Image moderation is also there. Now in the Google, that is an X, or this earlier it's Twitter and all these things. You know, when you are uploading picture in your Facebook or Instagram and all these things, right? Then that they will check whether this image will not harm to the society. They will directly post. If harm to the society, they will identify, detect it, and then review it. If it is not required, then it will not post, right? So the similar process, AWS Lambda and AWS Amazon recognition will play a very important role. That is, appropriate content detected. If yes, then picture posted. If not appropriate content, again this database is required. These appropriate contents or not, right? So that the machine learning model will do all these things. Okay, and machine learning model will do on this basis of the data. Again, sentimental analysis. This sentimental analysis, for that also we use the Amazon video streaming, and Amazon recognition is there. Amazon needs data stream, AWS Lambda, then again Amazon S3, and then it will be that's for the running images. We can do this also. Using the Amazon recognition, what we will get when you capture the image from the camera, we can see the bounding box. We already discussed about that. This bounding box is there, right? This is the bounding box, right? In this bounding box, we can say the top, left, and width and height we can get. So similarly, this top, left, and width and height, you can see here, this is what the bounding box and width, height is there. With the help of this, we can get the confidence with the model, right? And this confidence, this Amazon recognition will return all these things in JSON format. And this JSON we can use in your language and get the decision and all these things, right? It will see here the detect the label, detect the faces, and right, this picture is there. This picture will detect the label, detect the faces, recognition celebrities, detection of unsafe images, all these things. And then Amazon recognition will play very important role and give this type of JSON result. This JSON result we can use in our PHP, .NET or C++, Java, where with the help of this, we can take the decision whether this is a car or this is Apple or something else, this is a building or something is malicious or genuine or something, we can do that. Okay. This is what using Amazon recognitions. You can see that the image analysis also, right? The object and the sense detections are there, right? We can identify in this entire building. We can see that the persons, there is a 98.9% accuracy is there. Architecture 92%, car is the 97% accuracy. From this image, you can find out, you can classify this, and then we can do this. Road is there, street is there, urban is there. This Amazon recognition is a tool that can do very easily, right? This is what, again, the bounding box. You can see image in an object and sense detection is there, right? Again, in the case of face detection also, this type of bounding box is there. Bounding box, attribute, emotions, facial landmarks, quality, pose, and the confidence score is there, right? This, you can see that the face matches. How to compare these? Face matches, bounding box and the confidence, similarity score, facial landmark locations, stored face informations, unmatched faces, right? So if this, we have trained this particular face in this particular model, then Amazon recognition can recognize in a group of the image and then collect it and then give the this image string to the source, right? Must train the model, use the image with the target face and perform the facial recognition and store the facial metadata. So this again, Amazon recognition will play the very important role. This is one of the tool of the AWS for the computer vision. Okay, so this type of program, this type of output we have received, and on the basis of this output, face ID, external images, image ID, and similarity, what the similarity is 99.9, so that we can say that this particular image is present, this particular picture face is present in this image or not, right? So this is what the facial detection is based on the image data. You can see that, right? So there are a lot of things are available, but we have the time limit. I think I will stop here. If you have any questions, because we have 20 minutes of time, right? So otherwise we have the streaming video. On this streaming video also we can perform the same performance on this with the help of Amazon recognitions, right? Okay, thank you.
Thank you so much, Prof.
Yes,
we
because
have
of the time, because of time
we have a
constraint.
lot of material, but the time is very short. So
Right,
I will go ahead and just say, if anybody has just one question, one contribution, then we move over to the next presenter. If there is one, I will hand over to my colleague who is on site so that he can coordinate from on site. Thank you so much.
Thank you, sir. Thank you. Thank you. Thank you. If you have any questions, then you can just drop one mail to me, drdurgeshmishra@gmail.com. Okay. This is my mail ID. You can do drdurgeshmishra@gmail.com. Okay. Thank you.
All right. In case there are no questions, then we can interact during the break time.
Right.
I will hand over to my colleague who is on site to take over from now. Are we there?
Yes, we are, Prof.
Oh, thank you so much. Please go ahead.
Thank you. A very good afternoon, colleagues. I trust that we've been having an interesting conference thus far. I'm Gabriel Ninda from NAST, and I'll be taking over as second chair for this session. So up next, we have Prof. Meenakshi Tripathi, who's an associate professor at Malviya National Institute of Technology, Jaipur. And her topic is going to be on detecting cyber attacks in VANETs, advanced techniques and approaches. Prof, are you online? Prof. Tripathi?
Hello.
Yes, we can hear you.
Okay.
You are audible on our side, Prof. So I'll just read a quick bio just to summarize. I mean, it's a very illustrious one and really impressive as well. So Prof. Tripathi is an associate professor in computer science in the computer science and engineering department at MNIT Jaipur and received her PhD in computer science and engineering from the same institution. With over 14 years of teaching experience in computer science and information security and over 100 research articles, journals, and conference proceedings and books. Prof has already supervised 4 students PhD to completion and has about 5 of them, or more than 5 of them, working with her currently. Over 30 postgraduate students and 60 undergraduate students that she has guided for their research work. She has various professional designations, including being the Dean at Rajasthan Skilled University Jaipur. She's also a BOS member at the University of Kota and an ex-chairperson of CSI Jaipur chapter. She's also a BOS member of the Central University of Rajasthan, and she has various positions and credentials to her name, as well as a senior member of IEEE, ACM, and a lifelong member of CSI. And her research interests are in information security, wireless sensor networks, IoT, software-defined networks, and blockchain. So, Prof, if you are ready, we have, due to time constraints, we say please 15 minutes for presentation, and then maybe 1 question for Q&A, and we can then interact at a different platform if anybody has different questions. Are you ready, Prof?
Yes. So I hope my slides are visible.
Yes, they are visible and they are moving when you were just setting them up.
Okay. So first of all, thank you so much for the conference organizers and the Professor Dharam Singh ji for giving me this opportunity to interact with you people. Thank you all the participants for your time. So the title of my talk is Detecting Civil Attacks in VANET, Advanced Techniques and Approaches. I'll keep it general, but at the end, I'll mention the specific publications which are being done by us, our group. So if you want to know any specific method used by us, then definitely you can write a mail to me. And due to, as he already mentioned, due to time constraint, I'll move it fast. So this is the agenda for today. First, we'll talk about the VANET, characteristics of the VANET, challenges, civil attacks, and what are the detection techniques. So as we all know that if we just want to broadly classify the wireless network based on their the kind of establishment techniques they have used, we can classify them as infrastructure-based network, ad hoc networks, or the hybrid network. And again, if we classify the ad hoc network, then we can see the various kind of networks like wireless sensor network, flying ad hoc network means the drone-based networks, and the vehicular ad hoc networks. So the term ad hoc means anytime, anywhere, and for any application. So when I'm talking about the VANET, as you might have heard of this term, this is the vehicular ad hoc network, which is a very integral part of the intelligent transportation system. When we talk about the main components of it, then as shown in this figure, you can see it has the various vehicles which are moving on the road. And along with this, they have the roadside units, RSUs, gateway, and through these RSUs and gateway, they provide the internet connectivity. So when 2 vehicles are communicating with each other, we see that it's a vehicle-to-vehicle communication, and they use 802.11p protocol. And when a vehicle is communicating to either the RSU or if it is directly communicating to a hotspot, then it might use any of the Wi-Fi protocol, or they might use a cellular communication like your 5G or GPRS or LTE, any other kind of communication. And the ultimate point of communication of all these vehicles to each other is to manage the on-road traffic. so that we can reduce the congestion, we can reduce the accident in case of emergency. The information can be sent to the nearby hospital easily. So there can be many applications of the VANET. So if we talk about now the challenges of VANET, then as we said that it has, the nodes, the vehicles as the nodes. So that means it has high mobility because those nodes are continuously moving. So it might suffer the frequent disconnections and varying network density. Network density means the amount of vehicles which are lying at a under a particular range for a particular time period. So definitely, since the vehicles are moving, so this density keeps on varying, and it affects the stability and reliability of the communication link. So because of this high mobility, there is a severe requirement of quality of service kind of mechanism to handle this situation. Then it has dynamic topology because nodes are continuously coming in or moving out of the network. So it must require the routing protocols that need to quickly adapt to these changes, which can be very complex or resource intensive also, but there is a need for such kind of routing protocols. Then variable network density. It affects the availability of the communication paths and performance of the broadcast protocol. So it requires adaptive data dissemination protocol. And because it's very difficult to define the network boundaries. So whatever the protocols, whether it's routing protocol or security protocol, it has to be scalable so that the efficient management of the network resources can be done. Then the nodes are very heterogeneous. They vary in terms of their communication power, their computational capacity. So that is why the node should be such that the protocols should be such that they can operate with this heterogeneous node. So that means operability of the protocols such as DSRC, LTE, 5G should be there. And along with all these challenges, one of the common challenges, security and privacy, because the nodes are moving on the road. So it's not necessary that we are having only the legitimate nodes. There might be some illegitimate nodes who want to hack the information, who want to, mismanage the traffic, as well as since the data is moving over the air, so privacy of individual vehicle is also a very important concern over here. So if we talk about the attacks on the VANET, broadly based on the kind of security goal, we can divide it like this. And where, since my focus is on today's talk is on Sybil attack, so it is an attack on the authentication. So that means what happens in Sybil attack is a single malicious node illegitimately creates multiple fake identities and create the illusion of numerous vehicles. So as you can see in this picture that we have this attacker. So physical entity of the attacker is only one, but it has created these many fake identities. So how does it affect the overall system? There can be multiple effects. It can lead to incorrect navigation decisions, causing traffic jams, accidents, or inefficient use of road infrastructure. As you can see in this figure itself, that the victim vehicles are turning directions due to the congestion alert. And although there is no actual congestion doesn't exist over here, only the fake identities have been created. It can disturb the routing protocols by providing false route information, leading to packet loss, increased latency, and overall degradation of the network performance. And if we are using some kind of collaborative decision making, then it can falsely affect the trust and reputation system. So what are the various methods to detect the Sybil attack? First one is the statistical method, which is based on the concept of mathematics and probability to detect the inconsistency that might indicate the presence of multiple identities. And when we again classify these statistical method, then the first one can be entropy-based method. So what is the meaning of the term entropy? Entropy actually represents the randomness or unpredictability in the distribution of the node identities. So in case of Sybil attack, since a single entity, single physical entity is creating multiple identities, that means their entropy will be high or less. Any guesses? So in that case, the entropy would be less because the single physical entity is creating the multiple identity. So by calculating the entropy of node identity distributions and comparing it to a threshold, the system can easily detect the abnormal patterns indicative of Sybil nodes. Next method is behavioral analysis method. So where we can analyze the traffic patterns, such as what is the message sending rate and what is the interaction frequency. Because if there is any unusual traffic pattern, that means there are the chances of the Sybil node. Temporal analysis. How, at what time the different nodes are sending the message, by analyzing those patterns also, Sybil nodes can be identified. Statistical correlation. Correlation actually tells us about how the attributes of the two nodes are related with each other. So there are several kinds of correlation coefficients, such as Pearson coefficient, cosine similarity, Jaccard similarity. So by calculating these correlation coefficient, if we get the higher value of these correlation coefficients, that means these nodes are not the different nodes. So again, it provides an indication of Sybil identities. Cluster analysis. We can group the nodes based on their behaviors and interactions, and nodes that cluster too closely in their behavior again shows the presence of Sybil identities. So all those were the statistical method. Now next, if we talk about the RSSI based method, RSSI is what? Received signal strength indicator. So it analyzes the strength of the signal received from the different nodes. And in case of Sybil nodes, they exhibit same RSSI. Why? Again, the reason is same, because they are coming from the only one physical node. So that is why this signal strength would be same. So again, there are multiple methods. One is the RSSI consistency check, RSSI variance analysis, and then location verification using RSSI. We can apply various algorithms like trilateration, fingerprinting to estimate the position of each node based on the RSSI. And if multiple nodes are showing the same location, that means only one single entity is there, which is creating the multiple fake entities. So chances of Sybil nodes are there. Then we have the learning-based method. And for learning-based method, the methodology is same as we follow in all the other applications, that we need the data set, then we apply some pre-processing, then we extract the features, data balancing, and then we apply the various learning methods and evaluate the performance or classify the legitimate node versus Sybil node. These can be the various features. In case of learning-based method, mobility patterns, frequency and timing of the messages, interaction patterns, received signal strength. So this slide actually tells us about the comparison of these different methods based on the various features. So when we just look at this slide carefully, we can see that although the machine learning methods are highly adaptable and they are scalable to some extent, but they have very high computational complexity and their requirement is also high. So what is the solution? So the solution is we can use some kind of hybrid detection method, that we should not only dependent on the machine learning techniques, but we can use the combination of statistical and machine learning methods. We can use the combination of RSSI and cryptographic techniques. Why cryptography plays an important role here is because through cryptographic mechanisms like digital signature and all, we can provide the authenticity to a particular node. And Sybil node is mainly the attack on the authenticity of a node. Then we can use the blockchain-based technology also to identify the Sybil node, because in blockchain, we have a consensus-based decisions for the identity of a single node, as well as we can store the identity also in the block of that particular blockchain, so that nobody can modify it. And if there is alteration of identity is not possible, then definitely the Sybil node could not be created in that particular network. Trust and reputation based system. We can assign the initial trust to all the nodes, and as per their behavior, we can increase the level of trust. And when we have a certain threshold, when we have the number of nodes which have the trust higher than that threshold, then we can consider them as a legitimate node, and other nodes can be considered as the Sybil nodes. We have some collaborative detection approaches too, like the distributed detection, where nodes share information about the detected anomalies at the local level, and then at global level, some collaborative detection process can happen. So that means we can have a hierarchy of the anomaly detection. We can implement some voting mechanism where multiple nodes validate the legitimacy of a node. Then the last technique I want to focus over here is the cross-layer detection approach, that we should not just look at the physical or the network layer identity all alone, but we can combine the information from different network layers to improve the detection accuracy. And advanced learning algorithms, okay, it was not the last one, such as deep learning and reinforcement learning can also be used for the Sybil node detection. And these are some of our publication on the Sybil attack detections and other kind of misbehavior-based detections on the VANET. So if any one of you wants to know in detail, you can refer to these publications, and if you have any query related to these publications, you can ask me. I hope I have finished it in time, and thank you.
Thank you so much.
For any question.
That's exactly 15 minutes, Prof. So I think for that, we deserve a round of applause.
Thank you.
Thank you so much for this interesting topic. So I believe what we will do is then we'll just share the email address of Prof, so that if there are any questions, then they can be directed to you, just because of the time. And I will also maybe request Prof to share the slides, because I think I would be interested to look at those papers later on. Yes.
Sure.
Thank you so much, Prof, for that.
Thank you so much.
Yeah. So our next keynote speaker is Professor Dr. Nur Zaman Jani. I think I'm pronouncing it right. I'm so sorry, Prof. Who's a professor at the School of Computer Science at Taylor's University in Malaysia. And his topic will be on emerging metaverse opportunities and cybersecurity challenges. Now, I say colleagues because we are all researchers here. Colleagues, this is one of the most impressive bios I've seen in a very long time. Professor Nur Zaman is, I'm even starting to, it's so impressive. It's really impressive. He's a professor. Are you online, Prof? Let me start there maybe. Prof. Zaman? Prof. Zaman, are you with us?
Yeah. Thank you. Maybe you can join the internet side.
Okay, so while Prof joins us, perhaps we can move on to the next keynote speaker, and then Prof Zaman will be the last speaker. So, right, let me rather introduce Prof Akshay Kumar Rathore, I think. Prof, close enough?
We will know sometime else.
Okay, so Prof Rathore is a professor in the Department of Electrical and Computer Engineering in Singapore Institute of Technology. And the topic will be connected vehicles, technologies beyond electrification. Another impressive bio. I don't know, maybe let me enrich my vocabulary and just keep saying impressive. Because all our speakers' bios are quite impressive. So Prof Rathore is IEEE fellow and an expert in power electronics and control electronic motor drives. And Prof, are you with us?
Yes, I'm here.
All right, great. So from 2011 to 2015, he served as an assistant professor in electrical and computer engineering at the National University of Singapore. And from 2016 to 2021, he served as an associate professor in electrical and computer engineering at Concordia University in Montreal, Canada, where he also was listed in the Provost Circle of Distinction in 2021. So he also served as the graduate program director and chair of the graduate awards during the period 2020 to 2021, and is a recipient of the 2013 IEEE IAS Andrew W. Smith Outstanding Young Member Achievement Award, and also the Isao Takahashi Power Electronics Award, and also the IEEE IAS David Irwin Early Career Award. So Prof is an impressive researcher with over 105 IEEE transactions publications and over 300 research papers in international journals and conferences. So Prof, this is a very long bio, so to cut it short, I think I'll just refer everybody to the program. The full bio is in there. Prof, over to you. So we have 15 minutes for presentation. Thank you very much. Over to you, Prof. You may share your slides, please.
Yes, thank you very much. Can you see the slides?
They are loading. Yes, the slides are available.
Yeah, and are they moving?
Yes, they are moving as well.
Yeah, therefore, yeah. Thank you very much, and good afternoon, everyone in Namibia. It's evening in Singapore and afternoon in India. So the topic that I try to explain in 15 minutes is connected vehicles. So right now, everybody is talking about electrification. So moving from traditional gasoline-based vehicles, doesn't matter it is aircraft, ships, or cars, land, air, and sea, and basically transforming them through electrification from gasoline IC engine based to basically battery inverter and electric motor based engine. That is called electrification. But today we talk basically beyond electrification, that after electrification, what are the challenges basically still remain and how we can overcome that. Okay, yeah. Okay, so these are the initiatives by majority of the governments. There are so many summits and meetings happening in various parts of the countries. The representatives unite together and they try to basically take oath and claim that, okay, by 2030, 50, 70, we will try to achieve net zero decarbonization. And of course, net zero decarbonization can be basically achieved by two factors first. One is generation, which is 74% basically emission coming from generation and mobility. Okay, so can we do clean generation through renewable sources, and can we basically do clean mobility? Okay, no gasoline and no burning of the coal. Okay, so that is a mission of another 50 years in many countries except Norway. Norway is quite ahead. Okay, yeah. Now when it comes to mobility, then transportation manufacturing industries, they are advocating two kinds. One is electric based on battery, another is electric based on fuel cells. And both are doing quite well. Battery is quite picking up because let Hazel just charge it through the available AC sources. Okay, but hydrogen vehicles basically requires hydrogen refueling infrastructure and generation of hydrogen and transportation of hydrogen. That is a challenge. So nowadays, even for electric ship, the government of many countries, including Singapore, they are exploring the option of even ammonia, which is basically very easy to store and ship. Okay, but anyway, both are electric vehicles and they are the alternatives of the gasoline-based electric vehicle, a gasoline-based internal combustion engine. Okay, now moving forward. So suppose in future we will be having all electric vehicles. Okay, either hydrogen based or basically either fuel cell based or either the battery based. Okay, suppose this is the future that we are here for now. Okay, now what after that? Okay, now what after that? So sorry. So one thing you can see that more electric vehicle, which is fuel cell based or electric battery based electric vehicles, they will do clean urban mobility. Okay, but there is no control over traffic and safety. Okay, battery can catch fire, explosion, right? There have been cases on that. Okay, for lithium ion testing has been done, and accident can happen. Again, there is no control over it, and traffic there is no control over it. For example, in Singapore we have 1 million vehicles. Doesn't matter 1 million vehicles are gasoline vehicles or electric vehicles. If 1 million vehicles are on the road, traffic remain as it is. Collision issues remain as it is. Safety issues remain as it is. Only problem you solved is basically urban mobility, that rather than having tailpipe emission now will be cleaner. Okay. So now what to do? So instead of electrification, now this is the time for electronification. Okay. Use more electronics. All right. Make the vehicle smart. Make the vehicle intelligent. Okay, so that vehicle can identify which route is better where there is no traffic congestion, which route is better where I can save time to reach to my office or to my final destination, which route I should not go because there is protest going on and there is a road closure, which route I should not take because there is a landslide and the road is closed basically. Okay, so how to come to know this? You should have your vehicle smart, you should have some kind of info. Vehicle should be intelligent, should be giving you signal. Or safety, for example, another vehicle is coming at a faster speed, okay, to take over. Then there is a possibility that during, if you want to do basically blind check, and if you want to take basically change of lane, that vehicle can hit you. Accidents may not happen because you are a good driver. Accident can happen because somebody else around you is not a good driver. Okay, you want to do safe driving, but if somebody can hit you, you can't do anything with that. Okay, so can you have basically such kind of sensors? Okay, some kind of intelligence, such kind of alert signals appearing, so that at least you can do maximum possible actions to avoid accident. Okay, avoid such routes. Okay, so all those intelligence is basically coming through electronification, electronics, not coming through the electrical part. Inverter, motor, battery remain as it is. Now you have to move towards electronification. Okay, so this is electrification versus electrification. You have already done electrification from gasoline to battery based system, battery, inverter, motor. Now to avoid road congestion, to go for safety, and to save time, okay, then you have to go for electrification. Okay, that is also known as telematics, that we will see. Telematics means telecommunication plus informatics. Okay, so this is technologies beyond electrification. That's why the title of the talk basically, connected vehicles, technologies beyond electrification. We are talking about electrification now. Okay, these are some statistics. Still all over the world, approximately for 32,000 is for 10 years back. So we can say at least 30,000 people die per year because of the road accident. 30,000. Okay. $836 billion a year society loss happens because of the death toll basically. It could be because of the road closure. It could be because of the restoration of many things and because of the People lost their lives and because of the repair of the vehicle, etc. Okay, this puts the economy of the country behind. Okay, and always safety is the first priority. Doesn't matter what kind of vehicle you are driving. Okay, safety is the first priority. We have to try avoid the crash. Okay, now even if you have electric vehicle or a gasoline vehicle in cold countries like America, Britain, etc., there are sometimes the crashes or the accident happens due to slippery road that you cannot avoid. Doesn't matter what kind of vehicle you are driving. Okay, yeah. Okay, so now let us see that how connected vehicles can help in. So what we need to involve is telematics. Can all the vehicles can exchange data? Can you have sensors at various traffic lights? Can you have sensor at the basically point of importance, which can pass you some information and your vehicle can catch it? Okay. So these vehicles are also known as connected vehicle. Don't try to mix it with autonomous vehicles because autonomous vehicle, there is no man at all. It is making, the vehicle is making a decision, it is driverless. But connected vehicle has a driver, human is making the decision. Okay. Yeah. So now basically connected vehicles, it improves roadside safety, okay, enabling carpooling. For example, instead of 1 million vehicle on the road, you can avoid half of the vehicle if two people are sharing the ride, going to the same company, for example, from the same apartment, or on the way you can pick up somebody, okay, and then coming to the company with you and then again drop and then basically go to your house. If vehicles becomes half, then it basically reduce the traffic flow also. But how to know basically this? You should have some kind of apps on your mobile as well as on the dashboard of your car, because when you are driving you cannot see basically your phone. Okay, there's a crime also. Okay, you cannot see, you will get a bill. So somehow it should appear on the dashboard of your vehicle that somebody is looking for a ride on carpooling basis, and then basically it can reduce the traffic congestion. It also reduce the fuel consumption to quite less, probably half. So carbon footprint is reduced basically, and as well as fuel emission is reduced. All right. What we can do is smart integration of phone also to the vehicle. Okay, so that you need not to check your phone, but all the information is available on the app only, on the car dashboard. So what you need is basically cameras are needed on the traffic light, sensors are needed, radars are needed, light detecting and ranging devices which are for short ranges. Actuators can make basically can prompt the transducer to forward the signal, and quite more. It can recognize the object in the vicinity. Okay, if somebody is coming at a very fast speed, then basically you yourself make a decision to be slow. Okay, although the guy is overriding the rules, but still just for the safety of us. We can get the information of the weather, that the road is slippery, ice is there on the road, so basically we should drive slowly. So although the speed limit is suppose 80, but probably you need to drive at 30 because your vehicle has connected environmental data, and you know basically that you are not able to drive at that high speed, right? Yeah. So all this data from the various sources on the road, on the traffic light, you can connect and make your decisions accordingly, right? In addition to this data, what you need basically, in addition to this hardware that we discussed, you need this software, right? We need internet. If your vehicle is not connected to internet, then you will not get any data. Okay. If it usually this is wireless because you do not have the plug in the car, right? The data cable. It should be wireless. Communication system, okay, and cyber security, because the users which are transferring information to each other, they know your coordinates, so your safety can be compromised. So it should be done basically over a secure network. So it has cyber security issues so that nobody can even attack on your network also. Data reliability, that nobody is trying to basically transmit the fake data. Okay, so can you basically verify them? So altogether, this is called telematics, telecommunication over an informatics, right? So all these traffic signals are giving you data, and accordingly you can figure out that which route you can take to avoid the congestion, right? Similarly, vehicle to vehicle, they can talk to each other. Vehicle to pedestrian, because everybody has a smartwatch and a smartphone. So the pedestrian, although he is not in the car, but can talk to you and pass the information. Okay. Similarly, if there are vehicles at the traffic light, vehicle to infrastructure can pass the information to you. So accordingly, you can have a data that please reduce your speed. There is a long queue at the red traffic light. So don't try to come at the high speed unnecessarily, right? Yeah. Okay, so this is one real case when I was going in India from one city to another city. There was a basically rock fall, and the road was basically having a big dig, and it was broken. So basically, most of the vehicles were not able to pass by, and there was a traffic jam. If this information was given before, for example, some vehicle to vehicle connectivity, and it was shared rather than coming on the news, because once we are on the way, we are not basically assessing the news, we are not watching the TV. Okay. Yeah. Then there is a heavy traffic, and now this is only very small road, so you cannot reverse also. So if this information is already available, that one vehicle who reached there before can pass the information through telematics to all the connected vehicles, then you will not follow that path, and basically you will not stuck for 24 hours. Okay. Sometimes it happens. Okay. Similarly, once we have all these informations, so all these informations are basically getting recorded also. Since since you are driving a vehicle, so your driving data are also recorded. So based on that, all these informations are basically secured somewhere. That are you a good driver or a bad driver? You always followed the rule base, or did you meet any accident, or you tried to over speed or anything? If your data is quite good, then with the insurance company, you can negotiate also that I will take insurance from you, provided you give me the lower price, because you can see my driver record, okay, my driver behavior, right? And you can see that since all the information available through the sensors, so you can monitor the health of your individual vehicles. So suppose, for example, if you are having a company that is doing a moving business, so based on the information that which truck is basically in a better condition, you can allot that first, and then the one which is in unhealthy situation, you allot that in the last to your clients. Okay. And you can do predictive maintenance also accordingly based on the data that you have collected about your vehicle. Okay. Yeah, so this avoids basically since you have the dynamic tracking since you have the data, so you have the dynamic tracking of your vehicles, all the vehicles location. So already in the Uber and other kind of taxis, whenever you try to book a taxi, the taxi which is close by to you, okay, will come, and the taxi which has the
Professor,
basic. Uh-huh.
you have about a minute left,
Okay, sure.
just to move to conclusions.
Okay. Yeah. So
Thank
yeah. So these are some issues in addition to that. If all the vehicles are connected, then data overload issues can come. Electronic waste issue will be there. Okay. Data privacy, user trust, some legal and regulatory challenges, cyber security. These are the challenges that will come when we try to move from electrification to electrification and try to use this technology of connected vehicles. So there is some fair information policies there, principles are there basically that governments of various countries, FIPP basically, they are trying to apply to implement this kind of technology. But this will take years. Okay. Yeah, that is all from my side. Thank you very much, and we'll be happy to take any questions now or through email.
Thank you so much, Prof, for the presentation. I think a lot of people might be interested to perhaps have your email address just so that you can project it. And then if anybody has any questions, then they can reach out to you.
Sure, thanks.
Muchas gracias. I see gracias here. All right. So thank you very much, colleagues, for a very nice session. I think we have digested a lot over the past few, I think 2 hours or so. And I believe we can move into the lunch now. And then after that, we have a few parallel technical sessions happening. And they'll be happening in these rooms here. There will be some notes on the door just to let you know which technical sessions are happening where. So with that being said, it's lunchtime now. So let us go and digest that after we've digested this, and let us engage during those, during lunch. I would like to just give a challenge to everyone perhaps to say, after lunch, I hope you have new research collaborators that you'll be working with moving forward. So the technical session starts at 2 o'clock, so we'll munch a little bit faster. And I'm being informed now by some of the local chairs here that it's 2 o'clock sharp, Namibian time. Thank you very much and have a good day.
Thank you and have a good lunch.
Thank you, Prof. Yeah, I hope you'll be joining us virtually. You are with your food and us here.
Yeah, I will take my own food online.
Thank you.
पंखो करजो न। Hello, am I audible?
Yes, you are.
Hello.
Hello, I can hear you.
Yes, yes. Myself Sanjay Shah.
Yes, I can hear you.
Yeah, okay, thank you, thank you.
Hello? Is anyone there?
Hello?
Hello?
Yes, we can hear you.
Hello.
Partner that tells you Yes, sir. Hello, is anyone there? I'm not sure why I'm not seeing anyone or hearing anyone.
Yes, hello.
Yes. Do you know where everyone else is? I'm not sure where the presentations are
Yeah,
happening.
around 7 to 8 people have joined.
We are here.
Oh, so I don't see the presentation. Is the presentation going to happen in here?
Oh, no presentation is there. Only candidates have
No,
joined.
we don't know yet. We are still waiting.
Or the area chair is not here yet?
Yes.
Okay, thanks.